This question is from GATE Mechanical Engineering of 2014. This is question number 45 of set 3. The question is a fluid of dynamic viscosity 2 into 10 to the power of negative 5 kg per meter second and density 1 kg per meter cube flows with an average velocity of 1 meter per second through a long duct of rectangular cross section which is 25 mm cross 15 mm. Assuming laminar flow, the pressure drop in the fully developed region per meter length of the duct in Pascal is, we know that for a duct flow, we know the drop of pressure per unit length is given by 4 times of lambda into density of fluid into the average velocity square of average velocity whole divided by 2 times of diameter. Okay. Now, since this is a rectangular duct, so the diameter d will be equal to, the parameter d will be equal to 4 times of area divided by the perimeter of the duct. Okay, so let's write P for this. And lambda is 16 upon Reynolds number. Lambda is called the frictional factor. Now, if we substitute the value of lambda here, we'll get delta P by L will be equal to 32 times of dynamic viscosity multiplied by the average velocity whole divided by d square. Okay, and d we need to calculate. D is a parameter which is 4 times of area divided by the perimeter of the duct. Okay, so let's calculate all the values one by one. Now, let's first calculate the value of d. So d is equal to 4 times of cross sectional area divided by the perimeter. So this will be equal to 4 multiplied by area is 25 mm into 15 mm, and the perimeter of a rectangular duct will be 2 times of 25 plus 15. And this value will come out to be, so d is equal to 18.75 millimeter. So let this be equation number 1 and this be equation number 2. Now substituting the value of d in equation number 1, we'll get the drop of pressure per unit length will be equal to 32 times the dynamic viscosity, which is 2 into 10 to the power of minus 5 multiplied by the average velocity, which is 1 meter per second whole divided by d square. We just found the value of d, so it is 18.75 millimeter. So 18.75 whole square. Now we need to convert this into meters, so we'll multiply it by 10 to the power of minus 6. So after calculation, we can get the value of pressure drop per unit length, delta P by L will be equal to 1.8204 Pascal per meter. Okay, so let's fill in the blank. So the pressure drop in fully developed region per meter length of the duct is 1.8204 Pascal per meter. To get more information on duct flow, you can refer to the NPTEL course, lecture number 45, Pipe Flow, on Introduction to Fluid Mechanics and Fluid Engineering by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.